This is the second video regarding significant figure rules. The two rules we went over in the previous video discussed integers, which, if you recall, they always count. They're always significant. And then we went over zeros. And there were three types of zeros. It's zeros that are going to make students crazy. We have leading zeros, and they never count. And then we have captive zeros, and they always count. And then we have trailing. And trailing zeros count only if there's a decimal point somewhere. The next set of numbers we have to deal with for significant figures are exact numbers. Now, the definition says they have an infinite number of sig figs. I kind of like to think of them as they don't have sig figs, basically because you don't use them for significant figures. Example, conversion units. So if you convert a number, this is what I would like to think of as a known quantity. This isn't something you measured in the lab. It is a conversion unit. So we do not use to calculate significant figures. They don't play sig fig games, is another way to think of it. The second type of exact number we have is something that you obtain by counting. You know, if you have 9 pencils, there's no ambiguity there. You know there's 9. You can count to 9. Most of us can count to 9 without any trouble. Exact numbers, those that are conversions, those that are obtained by counting, these do not play sig fig games. You can say they have an infinite number of sig figs. Oh, that's not an infinity sign. That is, they have an infinite number of sig figs. Interestingly enough, rounding with significant figures seems to be one of the more difficult tasks for students. What we're saying when we say round this number to 3 sig figs is what I'm saying is I want this number rounded so that we are rounding to the nearest place value of that one. So we need to round to the nearest hundreds, because you can't change the actual value of this number. This number is approximately 15,000, and when you round to 3 significant figures, it still needs to be 15,000. Now, if I write 15300, does this number have 3 sig figs? Yes, it does, because trailing zeros do not count unless there's a decimal point somewhere, and there's not one. Another way I could have written this number is 1.53 times 10 to the 4th power. As you can see, here we say 3 sig figs. Try this one. We need to round this number to 2 sig figs. So here we're trying to round this number to this place value right here. So I'm asking you to take this number, sorry about that, and round it to the nearest 100,000. Can't change the place value on this, but we only need 2 sig figs. There's 2 ways to write this. You could write it 4,5 and then use a bunch of zeros. These trailing zeros don't count, or you could write it in scientific notation. Try this one. Round this number to 3 sig figs. I'm only interested in these first 3 digits. Would this work? No, it doesn't, because this is a trailing zero after a decimal point, so this does not work. Without this, the number's fine. This has 3 sig figs. These are leading zeros, they don't count. Could you write this in scientific notation, make it work? You betcha. There we go. Oh, that's a 4. As I alluded in the previous video, scientific notation is really simple with sig figs because with scientific notation, everything in front of this times sign is significant. So this number right here has 2 sig figs. How many does this one have? It has 5. I only caution you to make sure that the number is correctly written in scientific notation. If it is not correctly written, you will need to change it into the correct form to be able to look at it more carefully or accurately. Take a minute and see if you can solve all 4 of these problems on your own. Pause the video. I'll be back in a moment and see if you got them right or not. I'd probably put this one into scientific notation. I'm not sure of a really good way to indicate 3 sig figs and not have it in scientific notation. Oh, well, the directions say scientific notation anyway. Okay, give the next one a try. I made an error on that one. Do you know what the error is? Yeah, I put 3 sig figs. So this one really should be Now this one would probably give some students a hard time. Since I want 2 sig figs, I only care about these first 2 digits. This 9 says round that up. Well, yeah, that's kind of hard. Another way to think of it is, hey, this 199 is really close to 200, or 19.9 is close to 20. So what we need to do is round up to the next whole number. You try the answers to number 4 by pausing the video and then come on back and see how you did. If you do not understand why these are the correct answers, feel free to jot a question down and you can ask me in class tomorrow. Okay, take a look at these problems and tell me how many sig figs are in the following numbers. A sample of orange juice contains 0.0108 grams of vitamin C. If you said 3 sig figs, you would be correct. Leading zeros never count. Captive zeros do count. 3 sig figs. The distance between 2 points was found to be 5.030 times 10 to the 3rd feet. If you said 4 sig figs, you would be correct. Everything in front of the times sign in scientific notation is significant. A forensic chemist in a crime lab weighs a single hair and records its mass as blah, 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 blah. If you said 5 sig figs, you would be correct. Leading zeros never count. Captive zeros do count, and trailing zeros count if it follows a decimal point, or rather, I should say, if there's a decimal point somewhere in the problem. See how you do. Find how many sig figs are in the following problems. You can pause the video and write your answer, and then you can check and see how you did. This one should be 2. Trailing zeros count if and only if, you guessed it, there's a decimal point somewhere. This one has 3. These are leading zeros. They never count. These are trailing with a decimal point here. Everything in front of the times sign in scientific notation counts as significant. Infinite number of sig figs. We got this number by counting the number of cars. Oh, I'll go back so you can see it for just a little bit longer. Go ahead and pause this slide, give it a shot, and it's worth points. Just bring it in. Up next, we're going to use those sig figs to do actual calculations.